Good morning. So we're on distance learning. I can't believe it. I miss you guys already. Okay, so today's lesson we're going to talk about isosceles and equilateral triangles. We've kind of talked about that stuff, but now we're just going to go just a little bit more in depth. So you still have a test next Wednesday, even though we're on distance learning, still test next Wednesday. Okay. So let's talk about this. I have this triangle CAT, triangle CAT. So it says name the side opposite angle A. So if I'm looking at angle A, do you guys see that the opposite side is directly across, which would be CT? Okay. Name the side opposite angle C. That would be AT. Name the side opposite angle T. And that would be CA. Okay, now when we're naming angles, we can name them with one letter. So name the angle opposite side CA. That would be angle T. Name the angle opposite side CT. That would be angle A. And then name the angle opposite side AT. That would be angle C. So that's how you find the opposite sides. So let's talk about an isosceles triangle. So if you forgot, an isosceles triangle has two equal sides. Those two equal sides are called legs. If I look for the angles opposite those legs, this angle and this angle, those are called base angles. And the base angles of an isosceles triangle are always congruent. They equal each other. This extra angle up here, that's called a vertex angle. All right, so if two sides of a triangle equal each other, then the two base angles equal each other as well. So what if that triangle was turned sideways? Can you tell which two angles would equal each other? It would be this one and this one. So it's always those angles opposite those sides, okay? So if it's right side up, which two angles would equal each other? It would be these two, okay? And then vice versa is also true. If you know the two angles equal each other, then the two sides have to equal each other. Okay, and then on an equilateral triangle, if all three sides are equal, that means all three angles are equal. And so, do you know what all the angles in a triangle add up to? They add up to 180. So if you do 180 divided by 3, all three angles would have to be 60. Okay. I'm just going to go straight to your assignment and work some example problems, but I've got a couple jokes. What did the complementary angle say to the isosceles triangle? Nice legs. Why was the obtuse angle always upset? Because he was never right. And then I just thought it was funny. So there's snowmen, and one of the snowmen is eating a snow cone. Anyway, I thought it was funny. Okay, so let's pull up your assignment. Do you guys know the song, Jingle Bells, Batman Smells? Anyway, that's what this has to do with. I don't care what the song says. I don't smell. Okay, so let's do number one together. So you're going to look for each individual triangle. That's what you're looking for, is each individual triangle. So it says, use the picture to fill in the blanks. So first I'm going to look at AF. So AF is this side right here. So the triangle that goes with is the great big triangle. Notice the base angles are equal, so AF would have to equal AD, the other side. So you're looking for the triangle every time. Okay, so CA would be this triangle. Okay, so CA would equal, I hope you said GA. Okay, let's go to KI. So KI is this tiny triangle. Look at this little itty bitty triangle. So KI would equal KJ. Are you starting to get the hang of it? Let's look at EC. EC is this triangle. So which side would EC equal? I hope you said CD. And then you're going to look at JA. So JA is right here, which would go with this triangle. So JA would be BA. And I'm going to let you try the rest. Can you do the rest? I hope so. So look for the triangle that it goes with. Okay. Oh, there's only one more. I think you can do that one. Okay, let's go to number 2. So number 2, it's the same type of thing. So AB is right here. That's going to go with this other triangle, or this triangle, the top triangle. So notice the base angles are equal, so AB would have to equal AC. Next, we're going to look at the angles. So first, I have angle BDE. So BDE would be this angle. Well, that's going to go with this triangle, and do you notice these two sides are equal? So if those two sides are equal, the two base angles are equal, how could you name that angle right there? I hope you said BED. BED. And then the last one, we're actually looking at this middle triangle. Notice all three sides are equal, so that means all three angles are equal. We've named two angles. So I have CBE, CBE is that angle, and I have BCE, this angle. So I have to name that bottom angle with 3 letters. E has to be in the middle. My lights went off. E has to be in the middle. I'm going to try to get my lights to come on. There they go. So I would name that BEC. Okay. So I've got the first couple problems. I also want to do number 3. All right. So number 3, I have this equilateral triangle here, and then I have that isosceles triangle there. So equilateral, if all 3 sides are equal, that means all 3 angles are equal. And what is each angle if they're all equal? I hope you said 60. So I know all these angles are 60. And then on the isosceles triangle, I know these 2 angles have to equal each other. So if I do 180 minus 50, I get 130. What's 130 divided by 2? That would be 65. Okay, so now you're just going to go through and figure out what all those angles are. So for example, it says first find angle BCA. So BCA is that 60-degree angle right there. BCA, follow the letters in order. DCE is that angle right there, 65. So now you're going to look at some other angles. So DEF is this angle out here. And what do you know about these 2 angles? Well, they are a linear pair, so you would have to do 180 minus 65, and that's going to give you DEF. And I'm going to let you do that. BCD is this angle right here. So all 3 of those angles have to add to 180, so you're going to have to do 180 minus 60 and minus 65. So minus both of those to get that angle. Okay, BAG is this angle right here. So notice again we have a linear pair, and a linear pair adds to 180. So just do the 180 minus 60, and that'll give you that angle. And then I think the last one is this right here, G-A-H, GA. Notice those are vertical angles, and vertical angles equal each other. So that angle would be 60. Okay, so hopefully that helps with numbers 1, 2, and 3. So I'm going to kind of just guide you through a couple more. If you have other questions, please let me know. Please message me. Let me know. I will help. Okay, so this one, just notice that two sides are equal, so that means two angles are equal. So which other angle would be 50? So I hope you said C, and then you can do 180 minus 50 and 50, and that would give you the other angle. Notice if two angles are equal, then that means two sides are equal. So if those two sides are equal, you do not have to put centimeters. You can just put the answer, the number. If all three angles, or all three sides are equal, I hope you know what all three angles are. Okay, you're going to find the other angle that's 46, and then find the missing angle. These two angles would equal. Let's go. Number 11, you will get a decimal. Number 11, you'll get a decimal. So we could look at it if you want. So this is an isosceles triangle. So these two angles would be equal. So if you do 180 minus 75, you get 105. Then you're going to have to do 105 divided by 2, which is 52.5. So x would be 52.5, which makes that angle 52.5. And then vertical angles are equal, and this is also 52.5. So then you would do 180 minus 52.5 minus 52.5, and hey, guess what you're going to get? Y, which is 75. All right. This one, make sure that you look at your equilateral triangle first. So if all three sides are equal, then all three angles are 60. And then do you see that box right there? What's the degrees of that? That would be 90. So if you know this whole corner is 90 and this part is 60, that's going to make that 30. Well, then you have an isosceles triangle. So if that angle is 30, x has to be 30. So then you can just do 180 minus 30 and 30, or 180 minus 60, and that would be 120. Okay, hopefully that helped. Let's see. Okay, so look for your isosceles triangles. I think you can do that. I think you can do that. This one right here, so this is isosceles. So if this angle is 2x, this angle is also 2x. So if you do 180 minus 40, you get 140. Then if I divide by 2, I know each of these angles have to be 70, right? But 2x equals 70. So you're going to have to divide by 2 to get that answer, okay? All right. If two angles equal each other, then two sides equal each other. So you'll do 2x plus 6 equals 3x minus 6, and you'll have to solve from there. Let's see. Again, you've got an equilateral triangle. So all these angles are 60, and then you have that box there, which makes 90. So if this is 60 and the whole thing's 90, what would n have to be? That would be 30. And then you've got that triangle. 180 minus 90 and 30 would be 60. Okay. Oh, you will get a decimal there, I think. I think that one's a decimal. So what would y have to be if you know that's 60 and 60? Y would have to be 60, which makes that an equilateral triangle. So if this side is 4x, this side would be 4x, and that side would be 4x. To get the perimeter, you add all the way around. So 4, 8, 12x would equal 54. So just solve for x there. And I believe that's a decimal, so that's okay if you get a decimal. This is another perimeter problem, and that one's going to be on your test. So perimeter, you add all the way around. So if you know that this side is y plus 31, it's marked equal to that side, so that's also y plus 31. So I have y plus 31 plus y plus 31 plus y equals the 344. So that's going to make 3y plus 62 equals 344. You're going to solve for y. After you get y, plug it in to find QR. So you'll do whatever y is plus 31. To get angle Q, it's 180. If you know that's 68, this would also be 68. So minus 68 minus 68. That will give you angle Q. Okay. Let's see. Almost done, I think. Okay. So let's look at this one. I would start with this triangle. So it's an isosceles right triangle. So that means these two angles have to be equal. So if you do 180 minus 90, you get 90. And then divide by 2 to get each of these. So I know n has to be 45. 45, 45, 90. Then if you look at the big triangle, I'm going to draw it to the side. You know this is 50. So if you do 180 minus 50, you get 130. 130 divided by 2 would be 65. So I know each of these angles are 65. So I know this entire part is 65. If this piece is 45, this piece would have to be 20 because 20 plus 45 would be a total of 65. I hope that helped. All right. So again, we have an isosceles right triangle. So what's each angle here? So it says first think about it. What's the measure of each acute angle? So it would be 45. So to solve for x, you're going to do 2x plus 3 equals 45, and then solve for x from there. And then the last one, that is an equilateral triangle, so all three angles are 60. So you'll have 4x equals 60, and then this right here is a linear pair. So I hope you can do it. Please contact me if you have any questions. I miss you already.